Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna Dini.
Hey, Dianna. We got a question the other day.
Great.
That I thought would be a good thing to chat with you about. Is a little background is, I don't know, it was like a month or 6 weeks or so ago, somebody sent a question in, and it was looking for, is there a resource that lists all the failure mechanisms? And I think there's 1 or 2 episodes on that topic. And I even did a webinar about why we focus on mechanisms. But I don't know of a listing of all failure mechanisms. And the hard part is that every day another engineer designs something unique, or there's a new material available, or there's a new polymer available, or whatever. And we create all these brand new random ways things can fail. So it's a never ending list. But after all those discussions, I got a question a couple of days ago, and she asked, it was in the summarizing, but the basic question was, well, what if I'm looking at a product and I assumed it was in the design, it wasn't clear in the question. If I'm looking at a product, how do I identify which stresses I should pay the most attention to? And it was related to, then that would give me a clue as to which set of mechanisms may be at play. And okay. That's another way to look at it, is look, because there's fewer stresses than there are mechanisms. I thought, okay.
But she was still trying to estimate what failure mechanisms she should be looking for, or? Yeah,
it was like, where should I mean, think of it as part of the discussion went back and forth. It was like, if you're setting up environmental testing, or you're setting up a halt, you have to pick stresses to apply. Mm-hmm. And which ones do you want to accelerate, or which one do you use at normal use, and so on. And we rarely have the capability to do all the stresses that the product will eventually see in various combinations of simultaneously experiencing different things. So we have to break that down to the ones that are most important. And that's usually understanding the mechanism. But from looking at it from a stress point of view, in order to get to which stresses cause the most damage, is kind of like the gist of the question. And I'm like, well, that depends. And I think, I've looked at plenty of products over the years and said, oh, we should look at this, this, and this, but I've never stepped back and say, how do I know that? And so that was, I thought, might make a good topic to discuss with you.
Yeah, it might be your cumulative knowledge of just being a reliability engineer and seeing things happening, right?
Yeah. Oh, making things up too. I do a lot of that. So. Very, very creative when it comes to how things fail. I'm still basically a 5-year-old taking apart my mom's toaster. So.
Well, then you're doing the right thing.
Yeah.
If you get excited and it's fun.
Yeah. But the idea is, it's, when I look at something, I have that experience. And then when you look at stuff, you have your background and experience, and we can apply that. Yet that doesn't help somebody getting started. It's kind of painful to, I missed that, and now I know, but now you've missed it. And this product has gone off to the field and caused all kinds of problems. Yeah. So there's got to be a way to come up to speed on that. And that's the basic thought here.
Yeah, understanding failure mechanisms, there's a lot of ways you can try to get that information, and that might lead you back to which kind of stresses to apply. Is that kind of the way that you look at things too?
Well, sometimes. For example, years and years ago, a client said, "Hey, we're putting a satellite in orbit, and we're worried about the solder joints for the circuitry that's on this thing." And I says, what do you mean? And he says, well, it's in a low orbit and it goes around the Earth really fast. And so it goes from, minus 100 C or 100 to 200 degrees below zero to 100 above, like 80 times a day.
Well, he had the reliability statement all laid out right there.
Oh, he did. And I
Yeah.
said, we can't even do accelerated testing on Earth that efficiently. So you got to, you should. And he says, that's kind of why we're worried. And it was there, but they were deliberately knew that they were going into this low Earth orbit, and they knew the temperature was going to swing wildly. And weight and space and all that stuff just is horribly expensive. So they weren't going to be putting in heaters and insulating and all these other factors to mitigate it. I think it was one of the smaller type satellites. And it's like, you've got an accelerated test that we just can't replicate for solder joint fatigue, and they're like, oh, okay.
That's a shame.
But it's, there are steps you can do to mitigate it with potting and different kinds of solder systems and do through hole. And there are technologies that can withstand that, but they started with, we're going to space, and they were, bright enough to go, oh, well, that's going to be different than down here on the lab bench. So we need to take that into account, which is smart. Yet when you're building a brand new product, and you're saying, oh, it's going to be used by consumers in Europe and the US, for example, or worldwide, or it's a handheld product or whatever. There are vague tables and, listings and standards for environmental testing saying, oh, it's going to be dropped 10 times randomly onto, plywood or cardboard or whatever. But if you got a long list of these potential stresses, which ones matter? If you've got a limited time and budget and samples. So I think, how would you, other than our experience of looking at something, oh, a thing like this is what you need to look for, and that comes from experiences. For example, one step I would recommend is go talk to the design team and the developers and saying, what are the areas you're most worried about? What are the areas that are in your experience are the least robust? Which areas you think it's going to fail first? And that'll create a short list pretty quick.
That's true. And they would also base it off of how it needs to perform, because they designed it for that.
Right.
And they would also know more of the use case for it too. So I would hope so. They would design for the use case.
Yeah, that's worth checking.
So taking all of that into consideration, talking with the design team would help you get some of that baseline information that they should have designed to. The use space, and then and what it's supposed to do and perform, and what they think is the weakest part.
Yeah. Now, this goes back to experience, though, is that when I sit next to an engineer when we're running a halt on a prototype of theirs, I almost always say, all right, we're going to apply high temperature, low temperature, vibration, some power fluctuations, things like that. Which is the most likely to cause a failure, and when? When do you think it'll fail? And they're almost always wrong every time. And it's setting them up to be surprised by what the results are. And so it gives us a start, but a lot of designers underestimate the robustness of their own designs. And so one question to ask is what are the areas that you deliberately are making, like a mechanical engineer, you're deliberately making this thicker or stronger than it did? What kind of safety margin are you intuitively putting in places? Why is that? Well, we don't know what the variation of loads are really going to be. Oh, okay. So maybe it's applied loads or shock loads would be something we need to go explore. And would that be useful information to you, kind of thing. So that's one way, is with talking to the development team.
Yeah. And then if you're creating something that's brand new and innovative, you may not have a baseline of something to look at. But if you're iterating on another design that you already have, or that's already being produced, or maybe even a competitor is doing something similar, there is information out there. You just do a little bit of sleuthing to find out what are people complaining about, and what's failing, or um, what are they trying to do with it that it's not working or it's failing. Now, you're not going to get the specific failure mode, but that might give you some clues into um, what kind of stresses are causing failures in the field.
Mm-hmm. No, and even your own, product failures from previous, if you're using similar technology, you probably have your own field stuff. But the idea of getting your competitors, and I've recommended that to a handful of clients, that it was feasible for them just to go buy their competitors' products and tear them down.
Yeah.
Or run them in competitive testing, and over a range of different stresses. But the teardowns I remember one in particular is like, why are they using brass there? And we're using plastic. And, brass has got a lot of structural features that plastic just doesn't,
Mm-hmm.
and then you couple that with the discussions, the marketing folks were doing a lot of discussions with customers and saying, well, we just never have problems with this part of the product, and we have problems with yours. And it was some adjustment or tuning of some system. And the brass, and when we took it apart, it was like, well, maybe that's why this is all brass, why this is is metal versus a polymer. And so it was by looking at the design choices they made, it's a clue as to what stresses or features they're trying to enhance.
Yeah, so that's sort of borrowing from the the information that your competitors have about a similar product.
Yep. Yeah.
And there's even more and more expectations that designers and engineers look for that stuff. Just in the medical device industry, there's reporting requirements. Something bad happens with a medical device,
mm-hmm.
the users need to log it.
Yep.
And there's certain information about that gets published, and then the other manufacturers of similar devices are expected to be looking that up and tracking it and comparing their product against that one.
Yep.
So there is that information out there.
Well, there's a whole slew of different, it's more along the lines of product recalls. And sometimes they talk about what the nature of the failure mode is, or,
Mm-hmm.
Usually they focus on what's this thing can collapse and spontaneously combust, and it doesn't go into why or how, but sometimes they give you some clue at what's going on. But you're right. The medical field is one where they are trying to help each other. I just remember working with medical teams that they really never want to show up on there. It's just a fear factor for them that they ended up with these reportable incidents occurring. And so they do it. It inadvertently has this ability, in the design and development of their product, they're looking for anything that's reportable and try to design that out of the product, which in the long run, I guess, is a good idea, but it sure makes their process cumbersome.
I guess that's the fear-based reliability.
Yeah. It's not recommended, by the way.
No.
But yeah, the teardowns or what's available in the literature. I know Kirk and I were just talking about this in a recent episode, is that we rarely get good information on consumer products. If there's something failing, they might do a recall, but you never find out what really happened or what's the real underlying mechanisms. And
no, that's kind of secretive, right?
Yeah. And a lot of companies don't like talking about how things fail. And so they don't. And so we all, where what you just described with the medical group is they're at some trigger point, they're sharing this information so that everybody can say, hey, we need to avoid this. Now, one of the things I've learned over the years, and I started with this pretty early in my career, is that, we pay attention to what the functions are and what they're supposed to do and the quality of those. And we do the environment and the duration and probability, all this reliability stuff. But what we start our product with, and we set a guideline and we understand how the customer is going to use it, for example, the customers are going to change that almost immediately. They're going to use it in ways we never expected. And and I think as you're looking at stresses, it's here's what we would like them to do. you know, hold it like this, push it with this. I remember it was a medical device. It was a drug dispensing cart thing, and it had a keyboard on it. And they very quickly learned that they needed to make a keyboard that was resistant to the cleaning solutions they were using in these hospitals all the time. Right?
Yes.
And some were pretty harsh. And so they put a plastic or a coating over the keyboard. And the nurses and technicians that were having to use this piece of equipment found that they had to hit it with something hard. The pad of their finger wasn't enough to get through all the coatings to actually cause the switch to the button to activate. So when you type a 2, it takes a lot of work. So they all had pens. And so they took a pen and would push that into it. And so you ended up with all these holes in the coating that was to protect it from the cleaning solutions. And now you got all these openings for the cleaning solution to go underneath your coatings and hang out and never get wiped away and cause the more problems. And so I was like,
wow. Well, I mean, they had to use what was there, and so they had to modify it to be able to use it for themselves. If they couldn't push the button down,
yeah,
that was I would say that would be a requirement missed. That you wouldn't maybe necessarily think about. Yeah, the users have to be able to push the button with the pad of their finger.
That's right. And I remember talking to the mechanical engineer, and they're like, well, there's tables for, how light or how hard the range of people, men and women, they have all these biometric data, all this stuff. And so we picked a switch that was kind of in this range, and it should be fine. It says, yeah, the guys next door to you just put this rubber mat over the top of it. Oh, really?
Oh, no, they weren't communicating.
No. This is what we had to protect it from from the solutions. Oh, okay. And it was like, would that change the amount of force it takes to push these buttons? Oh, yeah. And then they also interviewed some of the nurses, and they said, well, if I touch it with my hand, I have to go wash my hands or change my gloves. If I pick up a pen and put the pen back down, I don't have to deal with it. And I was like, okay, it's a different use environment. But sometimes these stresses they're not just temperature. I think part of this original question was, if we have a thermal chamber, should we always use it? And I'm like, no.
No, yeah.
It brings up one of the things that is worth doing, and this is kind of what that example was about, is what's the day in the life of your product? How is it actually used? Is it moved? Is it got a chance to get tipped over? Is there button pushing going on? How often, how frequently, how hard, with what kind of tools? Is it in a daylight? Is it indoor or outdoor? Is it getting put on a vehicle, or is it stationary, but it could get run into or bumped into or knocked over? What's the temperature variation typically going to be? What's the humidity? How many bugs and rodents? And we were talking about squirrels in my garden earlier. It's like, how many squirrels you got running around? They will put an acorn in anything they can get.
Yeah, even that keyboard with the plastic covering on it. Yeah,
yeah, a bunch of acorns underneath it. But I often would go look at, there's a mill standard, and I've drawn a complete blank of what it is, that lists all kinds of environmental tests and how to do these testing. And for airborne equipment, satellites, for ground-based stuff, all kinds of stuff. But they list, 47 different stresses, including fire ants and fungus and stuff like that, which I would have never thought of. And so,
I've heard of fungus before. I don't think I would have thought of fire ants, but yeah, you see online people take pictures of the electrical circuit box for a piece of equipment, This is in Australia, I think. And they
Yeah.
opened it up and there's this gigantic snake
Yeah.
coiled around
That's
and
right.
everything.
It changes the conductivity and insulation properties a little bit.
It sure does.
Also,
So-
it makes doing any maintenance on it pretty tricky.
So, but I like what you said about, the day in the life of your product. And even from when it's sitting on the shelf in the warehouse and like you said, being transported around to getting boxed up and shipped and how it's getting shipped and how the customer's opening it and all that stuff has an effect on what stresses it sees and how it could affect that performance.
I remember doing that with a team. We're doing a handheld controller for a game system. And it's like, how is this supposed to be used? And is it like your typical game controller where you have your thumbs on triggers and stuff like that? No, it's different than that. And so we just kind of went through the different scenarios of what it was being designed for. And one of them was clapping. You were holding it in one hand and clapping with your other hand. And have you guys thought through how much shock that actually applies, and you're doing it repetitively for the duration of this game? And they didn't. So they did a finite element analysis where they were able to simulate essentially a hand clap, and we got some sensors and actually measured it, how much force different people would put on the product. And that circuit board inside that thing just was whipping all over the place. And the mechanical engineer, no, that'll never happen. So we took it to the lab and, had a controlled ball bearing-ish thing hit it with a certain amount of force. And it broke after the third time. The circuit board broke. The outside casing was fine. But the circuit board was just getting rattled all over the place.
I was going to say, I don't think I've ever seen a gaming controller like that. That might be why, huh?
Probably. I remember with one of the controllers, everything was the same controller. And one of the things that it was the Xbox controllers that I was talking to one of the guys about, and he goes, the number of times people throw it, they get mad at a game or outcome or whatever, and they throw it into the wall or into the TV and stuff. And that's usually not good for the controller. I says, that's probably not good for the TV either.
Well, and I would say that's misuse, right?
Yeah. He says, but it's, we take that into account as much as we can. You can't design it to work when it's encased in steel, but if it's more robust than you would have thought it would needed to be. But there's always stresses that you never imagine are going to happen. And it just takes getting the product out in the field and beta testing and getting people that are not the engineers that designed it to go try to use it and watch how they use it.
Yeah.
That's another technique, is to see how people use it. I remember one guy, he was trying to tell me that there was an interposer on a solder attachment, and had all these little spring-loaded levers things, these little shafts that would take up any dimensional differences from the IC to the circuit board, and it would create a good electrical connection and compensate for these small deviations and stuff, but allowed him to use it like in a socket, so you could replace the circuit, the integrated circuit, without solder, and it would clamp in and do all this other cool stuff. And he says, we've never had any problems with this. And this was obviously a sales guy. And so in 3 seconds, they said, what if it does this? And how'd you do that? And I've never seen that before. It's like, well, it didn't take much of anything. I just put my fingernail on it and went like that. And it goes, and I didn't even have to think about it. I was just handling it. And well, I have never seen anything like that before. That's unique. That's never going to happen in the field. Well, yeah, if I can make it happen, just wait. But yeah, it's a day in the life, some beta testing or alpha testing, get people in there to play with it, talk to the design teams, see what they're doing. Find those listings of environmental, whether it's mill standards, and there's various other standards in different industries that list all these tests that get done. And those are usually stress-based of some sort. What kind of stresses does the industry think is relevant for your particular product? Field data, What did I miss any that we chatted with? Day in the life?
No, I don't think so.
Yeah.
Just, any information that you have available that you may have to reach out for and communicate with people, but just try to learn what you can, and then that'll help inform or help you decide which stresses you might need to test for on your product.
Yeah. Now, I think we just came up with like 4,000 stresses for every new product. At some point, you got to start going, right, coupling it with what has caused problems for you. And what are the things that you're seeing in prototypes and early designs and areas of concern. Those are the priorities, I think, or anything new. If you just don't know how this material is going to behave, what are the stresses that are likely to cause it to fail? And you start from there. And
anything new, or what you think is the weakest component or weakest subsystem.
And then be prepared to be surprised, because there's going to be something lurking there that you just didn't anticipate. And at 22 Celsius and when it's powering up, it'll cause a problem. There's always, it just in my experience has been, be prepared to be surprised. But have fun. You get to break stuff. That's the best part. You get to break stuff. So anyway, I think we got a few parts to that. I'll have to revamp my answer to her to say, here's a couple other things to think of. So thanks for chatting with me on that.
No, thank you. Thanks for inviting me to talk about it.
All right, cool. All right. Well, thanks so much, Dianna. And if you're listening to this and I've got some other ideas of ways to, sort out which stresses and which mechanisms you need to pay attention to as you create a new product or a new system, let us know. Head over to accendoreliability.com/go/SOR. And there's a couple of ways to get in touch with us there. Dianna and I and the other hosts of the show are available through LinkedIn, and our contact information's on our About pages on the site. So we sincerely look forward to hearing from you and seeing what unique ways you can cause damage to your products.
Yeah, share it with everybody, then we'll all learn.
Exactly. All right. Thanks, Dianna. Talk to you soon.
Thanks, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.